Hi, I'm Chris, and today I'm going to go through the process I came up with for making a custom topographical pushpin map. This video will be split into two major parts, with the first part focused on how to design the topographical map files so that they can be laser cut, and the second part on how to assemble the map, with recommendations of what I would change if I were to do it again. And in fact, it took me so long to make this video that I actually did this project again with the changes that I'll be recommending, so I can show you what the results of that look like. This tutorial isn't meant to be all-encompassing, but will hopefully provide enough information so that anyone else can replicate the process without all of the troubleshooting and research I had to go through to figure out a way to do this. I also made a blog post for this project with more detailed information on each step, link below in the description. For supplies, the key ones you'll need will be the 1/8" cork board, plywood for the backing, and glue for assembling. I used regular wood glue and quick drying super glue. Also recommended is wood stain, a protective finish coating, and whatever you want to put on the map at the end, like string or pins. Besides that, you are going to need a laser cutter and software to create the laser cutting file. To do this, I used a program called Maperitive to generate the topographical data, and Inkscape to put it all together. Both are free and open source. And if you aren't interested in the nitty-gritty on how to create the laser cutting file, skip ahead to the time on the screen to me actually making the project. Moving on to the first step in this project, we are going to generate the topographical data for our map. The first way that I figured out how to do this was through a free and open source program called Maperitive. It is by no means perfect. In fact, there are a couple major issues that need to be worked around that I will explain, but it works, and it's the first way I figured out how to generate the topographical data. After you have downloaded Maperitive from maperitive.net, I recommend reading through the 2-minute and 10-minute introduction tutorials. Then, when you first open Maperitive, you are going to be greeted to a screen like this. Once you zoom and pan over to the area that you want, you're going to want to place geometry bounds like so. Next, we are going to try to generate relief contours, which can be done through the toolbar up top or customized below in the command prompt. When you try to run the function, you will probably get this error. The short answer to what is causing the problem is that Maperitive used to automatically download the elevation data from NASA, but due to a change in how that data is stored, Maperitive can no longer do that. The only way I found to work is to manually download and insert the elevation data into Maperitive. You can get this elevation data directly from NASA, but it's not stored in a format that makes it easy to manually download, at least if you're new to dealing with that kind of data type. My solution was using a website that I found that has an intuitive interface for downloading the elevation data based on a map. If you do use this site, you may need to download multiple tiles to get your entire area. As an example, I needed to download 4 of the tiles before I stopped getting an error in Maperitive. Wherever you get the data, once you download it, you will want to paste it into your Maperitive Rasters folder, shown here, which I believe defaults to SRTM3. And with that, fingers crossed, we can now go back into Maperitive and use the elevation functions like generate relief contours. Now, this function may work if you're making a small map, but because when you zoom out in Maperitive, the detail goes away, we don't have a way to export the data this function makes for larger maps. Thankfully, there is an alternative called Generate Hypsometric. Running it in its default format, we get a multicolored result, like shown. Though this isn't quite what we need, we can modify this function to our own needs. Inputting the following text below into the command prompt, I get this black and white map result. What this text specifies is that there are 2 layers generated, where all terrain under 1 meter is white and everything above 1 meter is black. And as will be explained shortly, this can be turned into layers that a laser cutter can cut using Inkscape. But before we jump to that, we are going to want to make one of these black and white maps for each layer in the final product. I did layers for 0, 250, 500, 1000, and 2000 meters. Once you have these layers, you will want to remove the map scale and grid from view, then place the printing bounds over the geometry bounds we made. and use the Export Bitmap tool on each layer we created. I recommend exporting the bitmap using the command prompt so that you can specify the file name and resolution that you want to export to. And now we move over to Inkscape to convert these images to vector layers. Inkscape is a great program, but it has a bit of a learning curve. A complete tutorial on how to use it is outside the scope of this video, so I'm not going to go too in depth on my steps, just in depth enough to show the process that I used. The first step is to import the images that we generated using Maperitive. It is recommended you utilize the Layers feature in Inkscape because you will want to keep each layer of the map perfectly lined up, and dealing with everything stacked on top of each other is going to get messy fast. The magic function that we are going to use is called Trace Bitmap. Because we made our image in black and white, the default setting should work perfectly fine. And bam! It's not immediately obvious, but we now have a vector copy of the image. We can now go down to the bottom left, and while holding Shift, click the red box. And then without Shift, select the X. Next, move our new vector to another layer, and hide the original image. And that's it! Well, sorta. While this is now in a laser cuttable vector format, it is very likely too fine detail for your laser cutter to cut, so you're probably going to want to simplify it. The first method to do this is literally the word simplify, which can be done by going up to Path and selecting Simplify. With the Nodes option selected, you can see how many nodes are removed by this function. This is a good start, but you may want to do more editing. After this, it is unfortunately all manual work. Cleanup can be done by going through and deleting nodes, smoothing sharp edges, and dragging lines around until you get the look you want. Another option worth mentioning is for high detail areas like the Puget Sound here. It might simply be faster to use the Draw Bezier tool and manually trace the complicated portions into a more simplified shape. And then you just need to rinse and repeat those steps for each layer in your map, with particular care taken to lining up each imported image with the original using the Align tools. This will make your life much easier later on. With all of the map layers turned into vectors, it is time to trim the map and add features that you want to raster onto the Cork layers. The rest of what I'm going to show in Inkscape is mostly optional depending on what you're going to do with your project. For this part, I'm going back into Maperitive to get another screenshot of the state, this time in the regular map view. After saving and importing it into Inkscape, I start by lining it up with the original layer image. Then I use the Bezier tool to trace the southern border of the state, which will be the final border for the map. I also use this image to trace the roads and add the text for cities. These will be the two main features that I raster onto the Cork. Next is cleaning up excess topographic geometry that we don't want. Using the southern border of the state as an example, I can use the borderline and a function called cutPath to split the extra geometry so that I can remove it. Now we go back to Maperitive to grab one last image, this time with the grid and legend made visible again. After importing and aligning the image, I add the first layer of the map and the outside border of the plywood base to trace the grid and scale from my plywood base background. Then I trace the latitude and longitude lines using path snapping to make sure the lines extend to all edges. Next, I copy the scale in the bottom left using the squares and rectangles tool. The border that I used for my map can be replicated using a similar process. Final recommendations include copying the next layer onto the one before it. This will make it much easier to glue the pieces on after you laser cut. You can also use the two layers to cut up the raster image, so that each layer rasters only what it needs when you laser cut. Here I have red as the layer being cut and blue as the next layer being traced. And that is the basics on how to design the file. I covered quite a few concepts pretty quickly. So again, if I went too fast on any of the parts, or you want more in-depth information on a step, I recommend visiting my blog post on this project. Now moving on to the fun part, we get to actually start making things. And the process for building the map is thankfully quite a bit simpler than the process for making the file. Starting with the laser cutting, the plywood base is simple enough. Just raster and cut it out. The cork was a little more challenging. To start, cork is essentially tree bark and glue, which doesn't make it the easiest material to cut. I tested 2 cork thicknesses. The first was 3/32, not quite an 1/8 inch thick, and the second was a 1/4 inch thick. In my tests, both rastered fine on the surface, and I was able to cut cleanly through the 3/32 cork, but my 50-watt laser cutter was not able to cleanly cut through the 1/4 inch cork. Ideally, I wanted to use the 1/4 inch cork board, since this is supposed to be a push pin map, and you need enough cork to stick the pins in with, but I wasn't surprised when the 1/4 inch didn't work, so I decided to go forward with the 3/32 cork board. The other challenging aspect of cork is that it loves to warp. Both of the cork sheets that I bought came in rolls, so as you can see when laser cutting, the cork has a tendency to warp pretty significantly, which is not ideal for laser cutting, because you want to keep the material as close as possible to the focal point of the laser. The best solution that I have found for this is laying down magnets, preferably neodymium for their strength. This is imperfect and pretty energy intensive, but it works. Next, I glued the pieces together. Now, after doing it the first time, for reasons I'll show when staining in the next step, I recommend flipping the gluing and the staining steps. The process for gluing is pretty simple. I used a wood glue for the large interior parts of each layer, and a quick drying super glue for the edges, so that I could quickly place each layer. For the first few layers, I put some heavy objects on the map for about half an hour to hold the layer down while the wood glue set, before moving on to the next layer. This step shows why I recommend etching the next layer onto the one below it. It would be an almost impossible puzzle to do this without the pattern to go off of. In the end, even though I thought I was meticulous about keeping track of the pieces, I still managed to lose a few of the smaller ones. So if you have any smaller pieces of your own, definitely be mindful about tracking them. Next is staining the map. I used 2 different colored stains, one for the wood base and one for the cork. When staining the board, you can see that the stain has a tendency to bleed into the cork, which causes uneven staining on the board along the edges of the map. And when staining the cork, you can see how some glue spots prevent the stain from soaking in, causing blotchy spots on the cork as well. So it's for both of those reasons that I recommend the staining first, if you're going to do it, to avoid those problems. Besides that, after staining, I sprayed on a couple coats of polyacrylic finish to give it a shiny top coat. And those are the major steps for making the map. I made this as a travel map, so as a final addition I added push pins and strings to the map. Now because the bottom layers aren't very thick, I had to more hammer than push the pins in to get them to stick. A bit of brute force, but still effective. Now I had a chance to go back and do this project a second time, so I can show what the results of my recommended changes look like. The biggest change was swapping the staining and gluing steps, which definitely helped the uniformity of the staining. Other minor changes included removing the mountains from the rastering on the cork, and shifting around the city text a bit so that no one letter was on 2 layers. Particularly with the mountains, it was just a bit too hard to read the text when it goes over multiple layers. And that's pretty much it. I hope you enjoyed the project, and that you learned enough to make one of these yourself if you want. I am very slowly figuring out how to make these video tutorials, so if you like projects like this, please consider subscribing. And if you have any constructive feedback to help me improve these video tutorials, feel free to share them with me in the comments below. Thanks.